26106 outlet device pull and junction boxes. So here's the code, NFPA 70, National Electrical Code, Article 314, outlet device pull and junction boxes, conduit bodies, fittings, and handhole enclosures. So a couple of things to note. It tells us about round boxes. Round boxes shall not be used where conduit or connectors requiring the use of lock nuts or bushings are to be connected to the side of the box. You can't do that in a round box. And non-metallic boxes, you can only use non-metallic cables. Non-metallic boxes shall be permitted only with open wiring or insulators, concealed knob and tube wiring, cabled wiring methods with entirely non-metallic sheaths, flexible cords, and non-metallic raceways. So 314.16 goes on to talk about the number of conductors in a box. We're trying to limit the amount of heat. That's what the code's all about. The code is about trying to eliminate the amount of heat in a box or a cabinet or a raceway. That's why we limit the amount of current in a conductor. That's why we limit the number of current carrying conductors in a conduit. If there are more than 3, we have to derate the ampacity. We have to limit the number of wires in a box. You can't just cram as many wires into that box as you physically can. They have to have a certain cubic inch area allotted to them in order to allow for cooling to dissipate heat. So 314.16, number of conductors in outlet device and junction boxes and conduit bodies. A talks about volume calculations. The volume of wiring enclosure shall be the total volume of the assembled sections and, where used, the space provided by plaster rings, domed covers, extension rings, and so forth, that are marked with their volume or are made from boxes or dimensions of which are listed in Table 314.16a. Where a box is provided with one or more securely installed barriers, the volume shall be apportioned to each of the relating spaces. Each barrier, if not marked with its volume, shall be considered to make up 8.2 centimeters, half square inch, a cubic inch, or 1 cubic inch if non-metallic. Standard boxes, the volume of standard boxes that are not marked with their volume shall be as given in Table 314.16a. So let's go on and look at 314.16a and b. Here's 314.16a, metal boxes. And they have round or octagonal boxes with the dimensions 4-inch diameter by 1.25 inches deep. It's 12.5 cubic inches, 4-inch, diameter, but that's how wide it is. By 1.5 inches, it's 15.5 cubic inches. Then they have square boxes, 4 by 1.25 inches, 1.5 2 1/8, 18 cubic inches, 21 cubic inches, 30.3 cubic inches, 4 11/16. That's a larger square box. 3 by 2 by 1.5 inches. This is a single gang device box. 3 by 2 by 1.5 inches has the screws on the outside of the box. 4 by 2 1/8 have the screws for the yoke of the device on the inside of the box. These are all device boxes, either 3 by 2 or 4 by 2 1/8, and then different depths and all their corresponding cubic inch areas of those boxes. They go on to tell us that if we're running all the same size conductor, if we're running all number 14s or number 12s, it says in a 4 by 1.25 inches deep square box, 18 cubic inches, we can put 8 number 12s or 9 number 14s or 10 number 16s. We don't use anything smaller than number 14 for branch circuit wiring. So usually 14 is about the smallest you'd need to go. Single device, let's say we have a box that's 3 inch by 2 inch by 1.5 inches deep. Well, we can only fit 3 number 14s or 3 number 12s. So that's pretty much a dead end. You cannot splice in that box. You cannot continue the circuit from that box. It's pretty much a one-use box. Now, each conductor has a cubic inch area. So a number 14 is 2 cubic inches. A number 12 is 2.25 cubic inches. A number 10 is 2.5 cubic inches. An 8 is 3, and a number 6 is 5 cubic inches. They're not saying that if you did the math on that conductor and you figured the cross-sectional area times the length, it would be exactly 5 cubic inches. They're saying you have to provide 5 cubic inches for every number 6 wire in a device box, again, for cooling, to have the ability to dissipate that heat. Earlier, we were talking about box fill and how you count for those conductors in a box. If we have a 4 by 1.5 inches and it says that we can put 6 number 12 conductors in that box, or let's say we have a 4 by 2.125 inch square, we can put 13 number 12 wires in that box. But what if we have some of the limitations? Box fill calculation, conductor fill. Each conductor that originates outside the box and terminates or is spliced within the box shall be counted once. And each conductor that passes through the box without a splice or termination shall be counted once. Each loop or coil of unbroken conductor not less than twice the minimum length required for free conductor, that's 6 inches, shall be counted twice. The conductor fill shall be calculated using Table 314.16b1. A conductor, no part of which leaves the box, shall not be counted. So, I know this is kind of a mess here, but the wire that originates outside the box and terminates inside the box will be counted once. And a wire that travels or passes through the box unbroken will be counted as one conductor. Conductor with 6-inch loop shall be counted twice. Okay, let's see what else we've got here. Let's see, the conductor fill shall be calculated using Table 314.16b1. We looked at that. Clamp fill. This is a cable clamp, something that holds the wire to the box. It's just one where one or more internal cable clamps, whether factory or field supplied, are present in the box. A single volume allowance in accordance with Table 314.16b shall be made based on the largest conductor present in the box. No allowance shall be made required for a cable connector with its clamping mechanism outside the box. So if you're using a Romex connector, and that Romex connector goes threaded end into the box, but the clamping device is outside of the box, you don't have to deduct anything for that clamping device. Some boxes have a clamping mechanism inside the box internally, and that's what they're talking about. They're talking about the internal clamping device. So here's a box with a clamping device inside the box. And remember, it said one or more. So if we have one or more, we only need to make a single volume allowance. Okay. Where one or more internal cable clamps. Support fittings, where one or more luminaire, stud, or hickey are present in the box, a single volume allowance in accordance with Table 314.16b1 shall be made for each type of fitting based on the largest conductor. Device or equipment fill. It says for each yoke or strap containing one or more devices or equipment, a double volume allowance in accordance with Table 314.16b1 shall be made for each yoke or strap based on the largest conductor connected to a device or equipment supported by that yoke or strap. A device or utilization equipment wider than a single device box, as described in Table 314.16a, shall have double volume allowances provided for each gang required for mounting. And And it goes on to tell us about equipment grounding conductor fill, where up to, 4 equipment grounding conductors enter a box. A single volume allowance in accordance with Table 314.16b1 shall be made based on the largest equipment grounding conductor entering the box. A quarter volume allowance shall be made for each additional equipment grounding conductor that enters the box based on the largest equipment grounding conductor entering the box. So for up to 4, it's 1 deduction, and then it's a quarter deduction for every ground more than those 4. Terminal block, where a terminal block is present in a box, a single volume allowance in accordance with Table 314.16b1 shall be made for each terminal block assembly based on the largest conductor terminated to that assembly. And then they go on to talk about conduit bodies. Those are C's, T's, LBs, LLs, LRs. Says only those conduit bodies that are durably and legibly marked by the manufacturer with their volume shall be permitted to contain splices, taps, or devices. The maximum number of conductors shall be calculated in accordance with Table 314.16b. Conduit bodies shall be supported in a rigid and secure manner. All right. So, let's see, what else did it tell us? Let's see, so here's my box. And again, it said that a conductor originating outside the box, terminating inside the box counts as 1. A conductor passing through the box with no splice or tap shall be counted once. If it has a 6-inch loop, it's counted twice. They said up to 4 equipment grounds are counted as 1 deduction, and every other equipment ground greater than 4 is a quarter deduction. So if you had 8, it would be a deduction of 2 of the largest grounding conductor in that box. They went on to talk about cable clamps. Actually, you know what? Let me make this a different box here. I'm going to make it a different box. Let's see, there we go. Here's a single gang box. So here's a single gang box, and it has a clamping mechanism inside the box. So when you bring the Romex, just use a red, when the Romex comes through the opening in the box and it's held underneath this cable clamp, and then you strip the jacket, you bring out the black, the red, and the green, the bare green. I'm going to use yellow as my neutral because you can't see white. It's a single deduction for this cable clamp, even if there are 2 of them. If there's 1 on the bottom and 1 on the top, it's still just 1 deduction. It's 1 deduction for each type of cable clamp. And they said that if you have, one of these, you've got, why am I using this when I've got my, okay, so if you've got a Romex connector holding your Romex, but the only thing that goes into the box is the threaded hub. It goes through the hole in the box, and then you put a lock nut on it. You don't have to count this. This isn't a deduction. They mentioned something called fixture hickeys. Well, they used to have a 3/8 red threaded hub in the back of a box, and then you could put a fixture hickey. And a fixture hickey, I don't know if I'm going to be able to represent this. If you ever see one in real life, consider yourself lucky. We don't use them anymore. I think I've seen 2 in my 30-year career. This is a fixture hickey. Basically, it has a small threaded end on this end and a small threaded end on this end, and you can screw it on the back of this stud in the back of the box, and then it hangs down, And then in this threaded side, you can put a fixture stud. And the fixture stud is just a piece of 3/8 all thread. And it's got a hole running up through the middle of it where the wires can be extended through this hollow, this all thread. So here are my wires, and they're being extended through the fixture stud, and the fixture stud is held in place by the fixture hickey. Sometimes you use a fixture stud without a fixture hickey. They have these brackets that get screwed onto a box that has a 3/8 threaded hole in the middle, and then you've got two screws, and the screws go up through the holes, and they mount this to the box, and then you can take this fixture hickey and you can thread it into this opening, if that makes sense. Okay, hope that clears it up and doesn't confuse you further, but anyway. So those are the things. If you have a fixture hickey, it's one deduction. If you have a hickey, it's one deduction. A stud is one deduction. Cable clamp is one deduction. The yoke, remember, the yoke is two deductions. If you have a yoke, it's two deductions per gang. So if this one takes up two gangs, it's two deductions per gang. So that's everything that the code was just telling us. Move that guy out of my way. And then here you can see the cubic inch area of the wires. So again, if you were using number 6 wire on a 50 amp range receptacle, it takes up two gangs. It would be a minimum deduction of 5 cubic inches times 4 deductions, 20 cubic inches. So you'd have to use a box that's a lot bigger than 40, a lot bigger than 20 cubic inches, depending on the wires that you have in there. So here's a 4 11/16 by 2 1/8, gives you 42 cubic inches. That's pretty good. You might be able to put it in a 4 square. That's 2 1/8 inch deep. That still only gives you 30.3 inches. I don't know if that's enough or not. I don't think it is, because you've got a deduction of 4 wires, and then you're going to have at least 3 for the 2 hots and the neutral. So you're going to be over. So you really need the 4 11/16 box for that. All right. Let's see, where were we? I wanted to show you that, so I scrolled back in okay. Devices and components. Let's see here. Where does it talk about? Here we go. Figure 14 provides additional information about adjustment required to calculate the total capacity of typical wiring setups and devices. Subtract the number of conductors as specified in the code from the maximum number of conductors permitted in NEC Table 314.16a. I don't like that depiction. They've got the copper going counterclockwise around that screw. We never do that. Always wrap your wire clockwise around your screw. So here again, all of these pounds, there's your green with a yellow stripe. That counts as one deduction. That's one conductor. And here are 3 neutrals and 3 hots. So that's 3, 6, 7. There are 7 deductions in this box. Although several equipment grounding conductors are shown, they count as only one conductor based on the largest conductor. Switches count as 2 conductors. Receptacles count as 2 conductors based on the largest conductor connected to a device. Here's a dryer. Dryer range receptacles count as 4 conductors because they take up 2 gangs. There you go. Here's a fixture hickey and a fixture stud. So those are each type is 1 deduction. If you had 1 of each, you'd have 2 deductions. Here's a highlight. It says where 4 or less, I should say fewer, but anyway, Equipment grounding conductors or equipment bonding jumpers enter a box. A single volume allowance must be made in accordance with NEC Table 314.16B1. And then it goes on to tell us about cable clamps. If the clamp is outside the box, it's one deduction. Box connectors terminating only with a lock nut inside the box need not be counted. Wire nuts and crimp connectors need not be counted in the volume calculation. Okay. Wires entering the box from a canopy. 4 or fewer fixture wires smaller than number 14 and that terminate within the box need not be counted. So if you have a ceiling fan or you have a light and that light has number 14 wires, you don't have to count them in your box fill calculation, especially because they have a canopy that gives additional volume. Grounding clips and screws need not be counted. Conductors, no part of which leaves the box, are not counted. But they did tell us if we had a terminal block, the terminal block is one deduction based on the largest size conductor terminated to that block. So here's an example. It says 2 number 12 gauge conductors are installed in trade size 1/2 inch GMT. They both terminate into a metal box that has one duplex receptacle. So we have 2 number 12s. There's a duplex receptacle. That's 2 more deductions. That's 4. And then I'm sure there's an equipment ground. That should be 5. What size box will meet the NEC requirement using the following step-by-step example? It says count the total number of conductors and other parts that will be used in the box. 1 receptacle is 2 conductors. 2 conductors plus 2 number 12 gauge conductors equals 4 number 12 gauge conductors. The total equals 4 number 12 gauge conductors. There should be a ground in there. I don't think they included the ground. Determine how much space you need for each conductor. It's a 2.25 cubic inch for number 12. So they're doing 2.25 times 4. So 9 cubic inches. 9 cubic inches. That's the size of box we need. Once you've figured out what size box you need, look at table NEC 314.16a. You'll see that a 3 by 2 by 2 inch deep device box is the closest size that will work. This box is rated for 10 cubic inches. Okay. So each conductor counts as 1 conductor. Each strap mounted device counts as 2. Each looped conductor over 12 inches counts as 2. Each fixture, stud, or hickey counts as 1. If you have 1 of each, it's 2. Up to 4 equipment grounding conductors counts as 1. 1 or more internal cable clamp counts as 1. Okay. 1.3.0, installing outlet boxes. It says some of the general NEC requirements are the box selected must be listed for the condition of use. For example, a box that's used in wet locations must be listed for use in that location. A box must have enough volume as listed in table 314.16a. The box must allow enough free space for conductors. This information is listed in 314.16b1. Conductors that enter boxes and fittings must be protected from abrasion. Boxes must be installed and supported properly. Once you finish the job, the box must be accessible for later repair or maintenance. So here's NEC Article 314, Part 2. That's where you find all of those code requirements. 3.1.3, NEC requirements for receptacle location. NEC Section 210.52 states the minimum requirements for the location of receptacles in dwelling units. In each kitchen, family room, dining room, living room, parlor, library, den, sunroom, bedroom, recreation room, or similar room or area, receptacle outlets shall be installed so that no point along the floor line in any wall space is more than 6 feet. We call this the 12-foot rule. This includes any wall space 2 feet or more in width, and wall space occupied by fixed panels excluding sliding panels. If there's a 3-foot wall with a door, you have to have a receptacle on that 3-foot wall because it's 2 feet or greater. You have to be within 6 feet of each door. So here's a sliding glass door, and within 6 feet of that door, you have a receptacle. Within 6 feet of this door, you have a receptacle. If this wall is greater than 2 feet, you have to have a receptacle. If this wall was greater than 2 feet in width, we'd have to have a receptacle. So within 6 feet of this wall, within 6 feet of this, well, this is a window, so I don't think we have to have, but you may not want to put the receptacles underneath the window. It says 12 feet max from receptacle. This is why we call it the 12-foot rule, because it's from 12 feet from this receptacle, you need another receptacle. They say no point along the floor line must be greater than 6 feet from a receptacle. So if I get 6 feet away, then I'm within 6 feet of this receptacle. I've never been further than 6 feet away from a receptacle, but the receptacles are 12 feet apart. So the code book never says 12 feet. The code book says no greater than 6 feet measured horizontally along the floor line. But we call it the 12-foot rule. Okay? 12-foot rule. And then there are other requirements for kitchens. You have to have countertop outlets serving the countertops. And those are the two small appliance branch circuits. Let me point something out to you. Or similar room or area. The code book knows that they can't mention every type of room. So this phrase, or similar room or area, means every room in the house. Kitchen, family room, dining room, living room, parlor, library, den, sunroom, bedroom, recreation room. You might have a room you call the conservatory. Well, it's a similar room or area. So it has to have receptacles within 6 feet of the door and every 12 feet. And any wall space 2 feet or greater has to have a receptacle on it. Or similar room or area. It says listed baseboard heaters including instructions that may not permit their installation below receptacle outlets. Informational note in NEC Section 210.52. So they might ask you a question on the test about baseboard heaters. You cannot install a baseboard, or you can't install a receptacle above a baseboard heater or below. Yeah, you can't install those heaters below receptacle outlets. A lot of those baseboard heaters will come with their own receptacles installed in the unit. That way, you don't have to install them in the house when you install those heaters, baseboard heaters. The sliding portion of a sliding door is not considered wall space when determining the placement of receptacles. So if we have, I always say, there. Oops. So let's say we've got wall space, and here's a wall. And then these people are rich, they live on the ocean, and they have 25 feet of glass windows. Well, if these windows don't move, this counts as a wall space. And you have to put receptacles every 12 feet. If you've got one here, you've got to put one every 12 feet, but it has to be a floor outlet because you can't put it in a glass wall. So use a floor outlet within 18 inches of the wall and everything's fine. Now, if these panels all slide, they move, well, now it's a doorway and we don't put receptacles in front of a doorway. So if this is indeed sliding panels, then, oh, what happened? I hit something with the palm of my hand. If all of these are sliding glass panels, then this is a doorway, and the only next receptacle would be within 6 feet of this doorway. So you'd have a receptacle on either side. I'm not going to say it wouldn't be a bad idea to put a floor receptacle anyway. That's depending, that's up to the architect and the homeowner. They may not want it because they don't want the look of it. They might want a floor outlet right here in the middle of the room. That's fine, you can have that. It doesn't count as those ones on the perimeter every 12 feet. It has to be within 18 inches of that wall in order to count as perimeter receptacles. So just know that. Okay. Oh, come on. All right. Fixed glass panels count as wall space when spacing receptacles. Floor receptacles required along the fixed glass panels if the receptacles on either side of the panel are more than 12 feet apart. When spacing this manner, a 6-foot cord will reach a receptacle from any point along the wall line. Receptacle outlets shall, when possible, be spaced equidistant apart. Receptacle outlets on floors shall not be counted as part of the required number of receptacle outlets unless they're located within 18 inches of the wall. We want to prevent or limit extension cords or cords of appliances stretching across fireplaces or doorways. That's why we want to put outlets on both sides of a door, and we want to put them on both sides of a fireplace. We don't want someone plugging in and stretching a cord across a fireplace. The NEC defines wall space as a wall that is unbroken along the floor line by doorways, fireplaces, or similar openings. Each wall space that is 2 feet or more in width must be treated separately from other wall spaces within the room. This minimizes the use of cords across doorways, fireplaces, and similar openings. Okay. At least one receptacle is required in each laundry area. You have to have a receptacle dedicated to a washing machine to do laundry. You don't have to have a dryer, not by the code. You can put a clothesline in your backyard and use that to dry your clothes. You have to have a laundry outlet, a 120 volt, 20 amp receptacle for your washing machine. But you don't have to have a dryer. It's optional. Within 3 feet of bathroom basins, on the outside of the building, and the front and the back, GFCI protected, on any balcony, deck, or porch accessible from the inside of the house, in each basement, in each attached and detached garage with electric power, in each hallway 10 feet or more in length, in each foyer larger than 60 square feet, at each accessible location for servicing an HVAC equipment. So there are no NEC rules about how high you can install receptacles or where you can put them other than the reference in NEC Section 210.52.4 for receptacle outlets 5.5 feet above the floor. However, if a receptacle outlet is installed in a countertop, several NEC rules apply. For example, 210.52.C3 states that receptacles shall not be more than 20 inches above a kitchen countertop. Also, 406.5G1 requires receptacles to be installed face up in a countertop or work surface application. Requires receptacles. I want to say that should have said prohibits receptacles to be installed face up. You're not allowed to mount them face up because stuff will fall into them. If you're in the kitchen, water and soap will get in them. If you're in a workshop, sawdust or staples or anything could fall in there. NEC Section 406.5G1 requires. I'm going to have to look at that. Oh well, we'll keep going. That's a good homework assignment for you. Look up NEC Section 406.5G1 in your code book and see what it says. In addition to these NEC rules, some methods of installing receptacles have become standard in the electrical industry. Figure 17 shows common mounting heights of duplex receptacles used in conventional residential and small commercial installations. So, over a countertop, usually 42 to 46, faceplates should be completely cover the wall opening and seat against the wall surface. Sometimes it's 15 inch. I always was told 18 inches to the center of the receptacle, to the middle, above the finished floor. Don't put them halfway into the tiles, either below the tile line or above the tile line. Don't split the tile line. The Uniform Building Code requires boxes on opposite sides of fire-rated walls between occupancies to be separated by at least 24 inches to maintain the fire rating. So you can't share a common area between two walls. If it's a firewall, you have to be separated by a 2x4. That way, the air cannot travel from one side of the wall to the other side of the wall. Look at figure 17 again. Height is measured from the floor to the bottom of the outlet box. Many electrical drawings give heights that go to the center of the box receptacle. When you're installing them, line up the bottom of the box with a chalk mark. This will be quicker and more accurate than trying to guess where the center of the box is located. Let's see here. Let's move on. Let's get on to something important. Holy moly, what's this? Gaps or openings around electrical boxes must be repaired. So they're saying that if this is greater than 1/8 of an inch, we need to repair it. Gaps or openings around outlet boxes must not be greater than 1/8 of an inch. Repair them if necessary. So be careful when you're cutting your boxes. You want to try to be accurate. 1.3.2 Making connections. Here's some general rules for installing boxes. Follow the electrical drawings. Space them as evenly as possible. You can find the center of the box by finding its vertical halfway point. Check the door swing direction. You don't want to install switches behind a door. You can't install a switch behind a door. It has to be opposite the hinge side of the door. Well, whichever way that door hinges, you want the switch so that you can open that door and reach into the room and turn the lights on. You don't want to have to step into a dark room and close the door in order to turn the lights on. They should be at the right height when installed. 48 inches to center is what I was always told, but you go by whatever your contractor says. Insulated spring connectors are sometimes called wire connectors or wire nuts. Here are wire nuts. These are examples of wire nuts. And the color coding makes them different sizes. These are actually orange. These are red. These are blue and purple. These connectors allow electricians to splice different solid or stranded wires together. Combinations of wires are usually used in branch circuit fixture splicing jobs. Several varieties of wire connectors are available. The following are used most often. Wire connectors used on wiring systems 300 volts or less. Wire connectors used on wiring systems 600 volts or less. Here's strippers. Get yourself a good pair of strippers. I like Ideal strippers. I'm not sure who made these, but Milwaukee makes a fine stripper. Like I say, I've always used Ideals. I've just gotten used to them. That's what I used when I first got into the trade. So it's what I've always used. Strip the insulation from the ends of the wire. That will be spliced. You'll usually strip off, I'm going to tell you 3/4 of an inch. They're saying 1/2 an inch. We're going to strip 3/4 of an inch and twist them together with our clines, and then we'll cut off any excess. But this may change depending on the wire size and the wire connector being used. There they're showing you. There's a number 12 wire, and they're using the hole that says number 12. And these are metric. They're going to crimp it down. Your instructor will demonstrate how to do this. In fact, we want to make some short videos on how to properly do this and put them on the site. But basically, it's a 3-step process. Nobody ever tells you this, but the first step is to bite the wire with the right size opening. And the second step is to relax your hand. If you keep a good firm grip on your strippers, they're cutting into the copper, and you're not going to be able to get the insulation off of the wire when you're biting into the copper. So after you've bitten through the insulation and you've separated the insulation, you need to relax if you're right-handed and you're holding your strippers in your right hand, relax that right hand, relax it, so that the strippers will open ever so slightly. so they're no longer coming into contact with the copper wire. Then you can pull off the insulation using your strippers. Wire connectors for wet locations. Some wire connectors are specially designated or designed to be used in wet locations and or direct burial applications. These wire connectors have a special material inside the body that completely seals out moisture and protects the conductors against wetness, fungus, and corrosion. I think they're purple. The special material is a gel that is designed not to melt or run out of the wire connector body. Unlike other types of wire connectors, this type can only be used one time. It cannot be reused. If it's ever removed, it must be thrown out. The wire connectors can be backed off so you don't have to cut the wires for future retrofit applications. And again, I believe that the ones for direct burial are purple in color. So here's your conical spring. It's a spring, but it's shaped like a cone so that it gets tighter the further you put it on. So again, your instructor is going to tell you how to do this. I say if you have 2 wires, you don't twist them. If you have 3 or more, you twist them. Some people will tell you never twist any wires. Some people will tell you always twist all wires. I say if you've got 2 wires, you don't twist them. If you have a solid and a stranded, don't twist them. If you have multiple solids and multiple strandeds, twist your solids together, twist your strandeds together, then just lay the 2 up next to each other. Let the stranded wire be a little bit longer. Just let it lead by 1/8 to 3/32 of an inch, just a little bit. Just let it lead a little. And then put the wire nut, the wire connector on there, the conical spring. It'll grab the stranded wire first because of the shape of the cone, and then it'll grab the solid bundle. So that'll keep it together. Yeah, it says get in the habit of making your connections in the following order. The equipment grounding conductor, then the neutral, the grounded conductor, then last but not least, the ungrounded conductors. When you're taking them apart, do just the opposite. Take the ungrounded conductors apart first, then the grounded, the neutral, then the equipment grounding conductor. All right. I'm an old man. I'm set in my ways. I don't like these. That's just an opinion. If you use them and your contractor buys them for you, if you like them, go ahead and use them. I don't like them. I want wire nuts that I can twist on, and I know that they've made a good connection. I don't trust these because I don't know how good of a connection I'm making copper to copper. And you can't twist them before you put this on. You have to just shove it on there. Let's see here. Here's our 1.0.0 section review. Octagon and round boxes are typically used to mount luminaires. Receptacle is usually located in a device box. A receptacle is a device. So they're usually mounted in a device box. If a box can hold 8 number 12 gauge conductors and contains it, oh, you know what? I'm not going to do these review questions anymore. I just remembered I wasn't going to do that. I had another instructor contact me, and he says that he has his students answer these questions, so he asked me if I would not answer these. So I'm not going to do the review questions. So this completes section 1, 26.106 outlet device pull and junction boxes. Let's move on to section 2.